guys! Welcome back to our Liceo Math Club channel.
For today's video, we are going to discuss normal distribution. I am Gracel Ferrer of STEM 11A.
And I am Elyza Illustracion of ABM 11A. And I am going to help you understand this lesson and gain more knowledge about it.
For our learning competencies, at the end of the lesson, I can illustrate a normal random variable and its characteristics.
Identify regions under the normal curve corresponding to different standard normal values.
Convert a normal random variable to standard normal variable and vice versa.
Compute probabilities and percentiles using the standard normal table.
So what is a normal distribution? Normal distribution is a probability distribution of continuous random variables. Previously, we have discussed the first type of random variable, which is discrete. For this week, we will be focusing more on continuous random variables. Many random variables are either normally distributed or at least approximately normally distributed. A normal distribution uses graphical representations of random variables obtained through measurements. Examples of these random variables are height, weight, and examination scores. Anything infinite really, as long as it can be measured, thus a continuous type of random variable. So this graphical representation is known as a normal curve. This is an example of a normal curve. Moving on, why do we use a normal distribution? For mathematical statisticians, they use normal distribution because it is easy for them to work with a normal curve. However, this is not only just limited for mathematical statisticians because teachers, students, scientists, and other people can also use it since a number of hypothesis tests and the regression model are based on the assumption that the underlying data has a normal distribution. One way of figuring out how data are distributed is to plot them in a graph. If the data is evenly distributed, you may come up with a normal curve. A normal curve is sometimes called as the bell curve. It is a distribution that occurs naturally in many situations. For example, how many jumping jacks can 16 members of the Liceo Math Club make without stopping? So first, place the gathered data on a table. So you can see the respondents are 1, 2, 3, 4, 3, 2, 1, which is equal to 16 members. It also corresponds to the number of probabilities. And the jumping jack is the values, which is 48, 49, 50, 51, 52, 53, 54. And if we are to plot it on a graph, it will look like this. And this is the shape of a bell curve. Furthermore, here are 6 characteristics of a normal curve. First is bell shape. So we have mentioned previously, the shape of a curve looks like a bell. Second, it is symmetrical about its center. If we draw a segment from the peak of the curve, this is the peak, down to the horizontal axis, the x-axis, the segment divides the normal curve into 2 equal parts. The left and the right are both equal. Third, mean, median, mode coincide at the center. This also means that in a normal distribution, or distribution described by a normal curve, the mean, median, and mode are equal. This is why the mean, median, and mode are called the measure of central tendencies. Next, the width of the curve is determined by the standard deviation of the distribution. The mean of a normal distribution determines the height of the bell curve. So if we draw 2 curves here with the same height, the other one here, they have the same height. However, this one is wider because it has bigger standard deviation compared to this one. So, the width of the curve is determined by the standard deviation of the distribution. Fourth, the tails of the curve are plotted in both directions and flattened out indefinitely with the horizontal axis. So here are the tails. The tails are thus asymptotic to the baseline. A portion of the graph that is asymptotic to a reference axis or another graph is called an asymptote, always approaching another but never touching. Lastly, the total area under a normal curve is 1. This means that the normal curve represents the probability or the proportion or the percentage associated with a specific sets of values. Standard normal curve is a normal probability distribution that has a mean of 0 and standard deviation of 1. So how do we draw a normal distribution? Here are 3 steps on how to draw a normal distribution. For example, the length of time it took truck drivers to go to Cadiz from Bacolod in minutes is normally distributed with a mean of 65 minutes and a standard deviation of 5 minutes. So step 1, sketch a normal curve. As we have learned previously the different characteristics of a normal curve, we can now easily plot it on the graph. So it will look like this. Second step, the mean of 65 minutes goes in the middle. So here's the 65 and it's in the middle. Third step and last step, each standard deviation is an interval of 5 minutes. So 65 plus 5 is equal to 70, 70 plus 5 is equal to 75, and so on. Same thing goes for the left side. However, you need to subtract it instead of adding. So 65 minus 5 is equal to 60, 60 minus 5 is 55. And this is how you draw a normal distribution. Moving on, the empirical rule. The empirical rule is better known as 68%, 95%, and 99.7% rule. This rule states that the data, A, and the distribution lies within 1, 2, and 3 of the standard deviation from the mean are approximately 68, 95, and 99.7% respectively. So, how do we read this graph? So, this is the mean, right? This is the mean. And if you add them together, it will result to 68%. And 68% of the data falls within 1 standard deviation from the mean. So, 1 deviation from the mean to the right and to the left is equal to 68%. Next, 95% of the data falls within 2 standard deviation of the mean. So 2 from the left and 2 from the right. So if you add this and this, and this and this, it will result to 95%. And next, 99.7% of the data falls within 3 standard deviation from the mean. So let's use a different color. If you add this, this, and this, 3 from the right and 3 from the left, you will get 99.7. With this 0.15% and 0.15% on the left are the margin of error. Moving on, what is the standard normal table? Standard normal table, also called the unit normal table or z-tables, is a mathematical table for the value of phi, indicating the values of the cumulative distribution function of the normal distribution. What you can see in the standard normal table are the z-scores. Z-score, also known as the standard score, indicate how many standard deviation an entity is from the mean, used to determine the area or percentage under consideration in a standard normal distribution. In order to get the z-scores, you need to take note of this formula. Z is equal to x minus mu over lowercase sigma. Or Z is equal to possible values minus mean values divided by the standard deviation value. There are 2 types of z-score table. the positive, and the negative one. The positive one means that the observed value is above the mean of the total values, while the negative one means that the observed value is below the mean of the total value. So how do we read z-tables? In order to read the z-tables, you need to locate the given z-values on the z-tables. Find the first two digits, whole number and tenths, on the left side of the z-table. Look for the remaining number, hundredths, on the top of the z-table. And third, the intersection of these numbers, A and B, will be the area from the mean to the z-values. Let us check an example. So here are two types of z-tables, the positive and the negative one. How we read this is based on what we just read. This is the whole values and tenths, and this is the hundredths values. For example, if we are to find 1.01, we need to first look at the left side, and you can see here 1.0. And in order to find 1.01, you need to drag and find 0.01. And 1.01 value is equal to 0.848. And that's how you read z-tables.
Let us now move on to normal distribution versus standard normal distribution, differentiating between these two terms.
The difference between the standard normal distribution and normal distribution is that the mean for the normal distribution depends on the given, while the mean for the standard normal distribution is always 0. We will know why later.
How do you convert a normal random variable to a standard normal variable? This process is called standardization, a process of transforming normal distribution to standard normal distribution. We use the z-score formula in transforming a normal distribution to standard distribution. The z-score formula wherein x is equal to possible values, mu is equal to mean value, and sigma is equal to standard deviation value. Example number 1. Determine the z-value for each of the following x values for a normal distribution with mean of 16 and a standard deviation of 3. For this example, we will going to use the z-score formula. For the first x value, which is equal to 12, z is equals to x minus mean divided by the standard deviation. We will now replace the following values in the z-score formula. 12 minus 16 divided by 3. So let us first subtract 12 to 16. And the answer is negative 4. Then negative 4 divided by 3. And the answer is z value is equal to negative 1.33. Let us now move on to the second x value, which is equal to 8. 8 minus 16 divided by 3. So 8 minus 16 is equal to negative 8. Then we will divide this by 3. Negative 8 divided by 3. And the answer is negative 2.67. X is equal to 22. So this is the z-score formula, and we're going to replace the value like what we used to the previous ones. Z is equals to 22 minus 16 divided by 3. 22 minus 16, and the answer is 6. And we will divide this by 3. And the answer is 2. Z-score Our z-value for this one is 2. And the last one, x is equal to 25. 25 minus 16, which is equal to 9. And we will divide it by 3 again. And we will get a z-value of 3. Okay. So that is how we compute for z-score using the z-score formula. We will now proceed to converting a standard normal variable to a normal random variable. So in this conversion, we will use a different formula. So this formula is x is equal to z value times standard deviation, and we will add this to the mean. So example number 1. A consumer group tested a sample of 100 light bulbs. It found that the mean life expectancy of the bulbs was 842H, with a standard deviation of 90. One particular light bulb from the Dura Bright company had a z-score of 1.2. What was the lifespan of this light bulb? So, in the given of this example, the given are the following. Z value, which is equal to 1.2, the mean 842, and the standard deviation of 90. So we will use this formula in computing for the x value or the lifespan of this light bulb. Okay, so first let us replace the following values, and it will be 1.2 times 90 plus 842. We will first multiply 1.2 and 90, and the answer is 108. After that, we will add this 108 plus 842, and the sum is 950. So the x value is 950. Final answer. The light bulb had a lifespan of 950H. We will now move on to the next, which is computing probabilities and percentiles using the standard normal table. First off, we will be discussing about or on how to compute probabilities. In computing for the probabilities, we will still going to use the z-score formula here. Okay, example number 1. The grades on a statistics and probability exam at University of St. Salle are roughly symmetric, with a mean of 92 and a standard deviation of 5. Bruno scored 87 on the exam. Find the z-score of Bruno's exam grade. Round off to the nearest 2 decimal places. So the given in this example are x, which is equal to 87, the mean, which is equal to 92, and standard deviation of 5. We will now replace the values given in the z-score formula. 87 minus 92 divided by 5. So let us first subtract 87, 92. And we have negative 5. Negative 5 divided by 5, which is equal to negative 1. So the z-score is negative 1. In other words, Bruno's score was negative 1 standard deviations below the mean. computing percentiles using the standard normal table. So what is percentiles? Percentiles is a term that describes how a score compares to other scores from the same set, finding the kth value. Example number 1. Find the 95th percentile. So there are 4 steps in finding the percentile. Let us first go to step number 1. Convert the percentile into a decimal. 95%. In order to convert this to a decimal, we should move the decimal point 2 places to the left, so it will be 0.95. After converting the percentile into a decimal, we will go to the step number 2, which is locate the tabular values closest to 0.95. So here is the tabular values. We will find the values that are closest to 0.95. So here, it is tabular values 0.94, 0.9495, the first z value that we found, and next is 0.9505. These two values are the closest ones to 0.95. Okay, so after finding the z values that are closest to 0.95, we will move on to the next step. To find the z-score of the following z values that we found earlier, we will go back to the tabular values. So first, for the value for the 0.9495 z value, we are in this 1.6 aligned to 1.6, and above this is 0.04. And we are going to add 1.6 and 0.04 to get the z-score of this value. So 1.6 plus 0.04 is equal to 1.64. So the z-score for the z value 0.9495 is 1.64. Let us move to the next z value, which is 0.9505, which is the same for 0.9495, which is 1.6 here. And above it is 0.05. So, like what we did to the previous one or to the previous Z value, we are going to add 1.6 and 0.05. So the Z-score is 1.65. So here, we are now done in our step number 3, which is identifying the Z-scores for the Z values. For the Z value 0.9495, the Z-score is 1.64. For the Z value of 0.9505, the Z-score is 1.65. Last step in finding the percentiles. Step number 4. Find the average for the Z-scores to find the 95th percentile. So, in order to find the average for these Z-scores, we are going to add these two Z-scores, which is 1.64 and 1.65. And the sum of these, we're going to divide it by 2. So here is the solution. 1.64 plus 1.65, and the answer is 3.29. And 3.9, we're going to divide it by 2. So 3.29 divided by 2. And the answer is 1.645. So the 95th percentile is 1.645. So that is how you compute or find for the percentile or the kth value. That's it for today's tutorial. I hope you have learned and gained a lot of knowledge and understanding.
Thank you for watching. Don't forget to like, share, comment, and subscribe.
See you
See
in
you
our
in our
next
next
video.
video. Bye!